All right, so in chapter 7, we're doing trig identities. If you're somebody who's done a trig class before, you probably will have a leg up in this chapter. For the rest of us who haven't been exposed to the trig identities, I love teaching this because it's brand new and I like to show you guys new things. So you probably noticed in semester 1 we had a lot of things that overlapped. Okay, semester 2 is a lot of new stuff. Okay, so you're going to notice there's going to be more mandatory assignments because these are brand new. Okay, but along with that comes more time in class to work on it. Okay, and then a lot of the stuff in chapter 7 is analytical. The whole chapter is called analytical trigonometry. So it's okay if it takes you some practice. There's going to be lots of different cases, and so we're just going to have to work our way through those. Okay, so we're going to be simplifying trig identities and verifying. So we're going to use a lot of substitution. And these identities are going to help us write expressions in different ways, okay, which is kind of what you started on that preview packet. So if you have a complicated looking expression, a lot of times we can write it as a simpler one. So some things we've used in the past to simplify are factoring. We've combined fractions with common denominators. And we use special product formulas, which are really just multiplying, right? So if you're doing the special product formulas, you can FOIL, okay, you can multiply together. So we're gonna use those along with the fundamental trig identities. So we're gonna list the reciprocal identities below. Again, these are things you've been introduced to before, but we're going to be using them in different ways now. So the first one we're going to write is the cosecant. So the cosecant would be equivalent to 1 over sine. The secant is equivalent to 1 over the cosine. Okay, what this also means is if you were trying to rewrite the sine, you could rewrite that as 1 over the cosecant. Okay, we'll more commonly use this one, but these are true as well. And if you're trying to rewrite the cosine, you could do 1 over the secant. Okay, and then when you have the cotangent, you have 1 over the tangent. When you have the tangent, you could do 1 over the cotangent. But remember, the tangent is special. So you could also write it as sine over cosine. Okay, that's going to be something we're going to use a lot in this chapter. And if these are reciprocals, if tangent is sine over cosine, we know that the cotangent is the cosine over sine. And when you guys are writing these out, remember to keep a variable with it. Most commonly, you're going to see x and theta, but there are some other Greek letters that are going to work their way in there. Yeah, the theta. Yep. And then we're also going to be using the even and odd identities more. Okay, so the even identity is cosine and its reciprocal. We're just going to write down the cosine, okay? But the same property is going to apply to its reciprocal. So if it is even, that means if you take the cosine of the negative value, that's going to be equal to the cosine of the positive value. Okay, so the cosine of negative x is equal to the cosine of x. Okay, and then the odd identities are the sine and the tangent and their reciprocals. Okay, so if you have the sine of negative x, that's going to be the same the negative sign of x. And the same thing happens with your tangent. Okay, so the tangent of negative x is the same thing as the opposite tangent of x. Okay, so we are going to be using those a little bit more. Okay, now there are going to be Pythagorean identities. The first one we're going to write down is going to be the one that we are going to use the most. Okay, and this is the one that you will want to have memorized. So it is the sine squared plus the cosine squared. Some of you know what it equals? 1. Sine squared plus cosine squared is equal to 1. Okay, so this is the most important one, so we're going to box it in. It is very similar to that, yeah. Okay, and then from there, we can find all the rest of them. Okay, so as long as you know this, the rest of them you can derive from that. So if you want to find the next Pythagorean identity, all you have to do is divide this box. So divide what's in box 1 by the cosine squared. Okay, so we're going to divide everything in box 1 by the cosine squared. Okay, so if you do sine squared divided by cosine squared, what's that going to be? What's sine squared over cosine squared? Tangent squared, yeah. Okay, and then plus, what's the cosine squared divided by cosine squared? 1, yeah. Anything divided by itself will be 1. And then 1 over the cosine squared, we're going to use our reciprocal. So 1 over the cosine is the secant. Yeah, so it's the secant squared. How do you think we're going to come up with the next one?
Divide the first box by
Yep. Divide box 1 by sine squared. Okay, so I want you to give that a try. Okay, so write that identity. You're going to divide each term. All right, and then Lucas, can you tell me what you got for that one? Yeah. Nice. Okay, so when you divide by sine squared, you get 1 plus the cotangent squared equals the cosecant. Okay, sine over itself is 1. Cosine squared over sine squared, cotangent, 1 over the sine squared, the cosecant. Okay, now all the rest of them, okay, we're going to use subtraction. So from the first equation, so this top row here, we're going to use subtraction to write 2 equivalent properties, and we're going to put those in the corresponding boxes. Okay, so let's do the first one together. Okay, so if I wanted to rewrite this for sine squared, okay, to move this over, I would have to subtract, right? Okay, so if I subtract the cosine squared from both sides, I'll just have 1 minus the cosine squared. Okay, and then see if you can do that for your cosine squared here. then see if you can go to the next one as well. And then I'll come around if you have trouble visualizing that. Okay, and then Solomon, what'd you get for this one? What'd you get for the cosine squared? Nice. All right, and then Nina, what'd you get for the tangent squared? Do the opposite. So do -1, -1. So it'll be the secant squared -1, like that. Yep, from both sides. Okay, and then Harrison, what'd you get for the last one?
1.
Yep. Okay, so to move this over, we'd subtract it from both sides, so we're always going to start with that. So this one we started with 1 because that was on the right side. This one we start with secant squared because that's on the right side. Okay, and then in your last column, did you guys already do that, or do you need a second? Okay. All right, so Kristen, what'd you get for the cotangent squared? Good. Okay, and then Farrah, what'd you get for the last one? Nice. Okay, so again, this is going to be the most useful, what we have highlighted here. The other ones we're going to use the most is everything in this first column. So sine squared is the same as 1 minus cosine squared. Okay, cosine squared is the same thing as 1 minus sine squared. Now this only is going to work with the squares. So you can't say sine plus cosine is 1. It's sine squared plus cosine squared is equal to 1. Okay, so we are going to write the trig expressions in terms of sine and cosine, and then we are going to simplify. Okay, and then as we do this, one of the main things that we want to make sure we develop is reasoning and proof. So not only, hey, we know how to do this, but we know how to justify the steps that we're taking. So there are some of these where you're going to have to set it up like a proof and give a reason. As we do some of these steps in the first example, I am going to write the reason down so you know why it's okay that we do those. All right, so for part A, we have 1 plus the sine of y, and then the secant of y minus the tangent of y. Okay, again, just make sure that you have the variable with your trig function. The trig functions always have to be of something. Okay, and then the directions say to rewrite with sine and cosine. So I want you to think about which one can you rewrite with sine and cosine. So some of them may already be simplified. Some of them we are going to simplify together. Okay, so as we get started, we have 1 plus the sine of y. We're going to leave that. But the secant, we can rewrite as 1 over the cosine, so we're going to do that. The tangent, we can write as sine over cosine, so we're going to do that as well. Okay, and again, the directions tell you to rewrite with sine and cosine, so that's how we know how to start there. Notice that you have a fraction here. So if you have a fraction with a common denominator, all you have to do is subtract. Okay, so if I'm subtracting, it's just a 1 minus the sine of y over the cosine of y. Okay, and then that's still being multiplied by 1 plus the sine of y. Okay, for some of you, the hardest part is going to be making sure you write out your steps each time. Okay, so you do have to make sure you follow those from one to the next. And then you have a fraction times a whole value. Anytime you have a fraction times a whole value, make this into a fraction so that you can multiply. So if you're multiplying the numerator by a numerator, in this case, you're going to FOIL. Okay, that is something that you did on the preview worksheet. Okay, so if I'm FOILing, I have 1 times 1, and then plus the sine of y, minus the sine of y, minus the sine squared of y. And all of that is going to be over the cosine of y. So 1 times the cosine is going to be the cosine. Okay, so we're FOILing first, and then I do the inside, then the outside, then the last. 1 times cosine is cosine, and now we can combine like terms. So sine and negative sine will cancel. Okay, and I'm even okay if you, like, when you FOIL, you just go straight to this step, that's fine. Okay, now right now, you might not see this right away. As we practice, this will be one of the things that you will notice. Okay, when you have 1 minus the sine squared, that is equal to the cosine squared. Okay, so anytime you have 1 minus sine squared or 1 minus the cosine squared, you do want to rewrite that using your trig ID. This is a Pythagorean identity, so we're going to be abbreviating that. Okay, so this is the cosine squared divided by the cosine. If you have cosine squared divided by cosine, what does that equal? It's the cosine squared divided by cosine. Yeah, just cosine. Okay, anything squared divided by 1 is going to leave you with 1. So this is going to be your final answer, the cosine of y. All right, how do we do? See, it's a little bit different than things that we've done before. So we're going to be using a lot of logic, a lot of substitution. Okay, now when you are simplifying these, I just want you to know that many times there is not only one way to simplify it. Okay, sometimes there are multiple ways, and that is okay. You're going to choose whatever comes to you first. Okay, and that might be different than the person next to them. So multiply by yep, so the sine of theta plus cotangent of theta times the cosine of theta over cotangent. Okay, so I want you to go ahead and just like we did with the first one, I want you to go through and replace everything with sine or cosine if it's not already a sine or cosine. So if it's already a sine, that stays the same. Okay, I can rewrite cotangent as, Jaden, how would I rewrite that? Jaden C. Great, yeah. Okay, cosine over sine. And then it's still multiplied by cosine. And then you have the cotangent again, so it's just cosine over sine. Okay, so you can decide what you like to do next here. You should multiply these two to simplify them together. Just be careful because they don't cancel, right? This is like over 1. So this is cosine squared over the sine divided by cosine divided by the sine. Okay, I want you to think about what you can do next. This is where you can really go 2 different ways. So what do you guys think? Yep, so you can add the 2 expressions in the numerator, so it's 1 term. And yeah, you can do that. Yep. Yep. So you can get a common denominator on the top. If you wanted to split those off, you could do that. Even if you wanted to do the keep, change, flip now, you could do that as well. So any of those are fine. Okay, so a lot of times before we do the division, okay, we've gotten the LCD on the numerator. Okay, so if I want them to have the same denominator, to simplify, I'm going to multiply by sine over sine. Okay, and go ahead and simplify what your next step is. All right, so then double check that you have this correct. You'd have sine squared plus cosine squared over the sine divided by cosine over sine. Okay, and then you can decide what you do first here. For ones like this, if you want to do 2 of them together, you can. Once you have it into 1 term, you can do keep, change, flip, or you can multiply by the reciprocal. Okay, some of you might want to put the trig ID in right now. That's fine too. Okay, so if you keep the numerator, change this to multiplication, and then you flip the denominator, okay, you can simplify the sine divided by sine. Okay, those are going to cancel. Okay, this is a Pythagorean ID, the sine squared plus cosine squared. Okay, so that's going to give you 1 over the cosine of theta. And like I said, if you want to simplify that earlier, absolutely. Okay, and then 1 over the cosine is one of our reciprocal identities. So your final answer is going to be the secant of theta. Okay, so don't leave it as 1 over cosine or 1 over sine. Make sure that you end with that reciprocal identity. Okay. okay? So for those, you just need to make sure, like you're writing out your steps. And then the next thing we're going to do is we are going to prove trig identities. Okay, and when we do these, we are going to have a justification for each step. Okay, it is very similar to what we did here. Okay, except you are going to have an equation instead of just an expression. Okay, so when you are proving the trig identities, you're going to start with one side. Okay, notice that it says here that your goal is going to be to transform it to the other side, and it's usually easier to start with the more complicated side. Okay, so you always pick one side. Your goal is to, do you have a pass? Oh, we just showed it. Okay, and then you can also use your known identities. Okay, and then you're going to be using these identities that we talked about today, and the reciprocal and the even and odd. Okay, so you can use those to change the side that you started with. You're also going to be using strategies like getting a common denominator, factoring, and those fundamental identities. Okay, and the first thing you really should see is if you can convert anything to sine or cosine. Okay, so you're going to start with the more complicated side, and then if you get stuck or if you're not sure where to start, okay, this is going to be helpful tips. I'm going to give you 5 things to try when you get stuck, okay, and it's okay to get stuck because there are going to be times. Okay, so the first thing you want to do is rewrite with sine and cosine. Okay, if you aren't sure where to start, start there. Okay, if you can't rewrite with the sine and cosine, then the next thing I recommend you check is see if you can do a substitution, okay, with the identities. So I'm just going to put the IDs. So identities can be a reciprocal identity, can be even and odd, can be Pythagorean, any of those. Okay, if that doesn't work, see if you can factor it. Maybe you have fractions. If you do, get the LCD and combine your fractions. And then the last one is going to be to multiply by the conjugate. Okay, so that is a really helpful list. So if you're not sure what to do, I want you to go through that list and see. Okay, now one of the most important things is you do not perform operations to both sides to prove an identity. This is the same thing with checking, like how you don't work with both sides. Okay, and it's not valid because you would have to assume the equality to be true. Okay, you can't assume they're equal because we're trying to prove that they are. So we're only going to start with one side, and you have to work your way to the other side. Okay, an example of why we can't do that is something like this, where if you have the sign is equal to the negative sign, if you squared both sides, yeah, they'd be equal, okay, but we couldn't derive this step from step 2. So it wouldn't be reversible to go back to what we just did. Okay, so that wouldn't be proving that identity. Okay, and then when we are verifying the identity, we are going to write a reason for each step. Okay, so you're going to write a reason to justify each step. And there's a couple different ways you guys can write that down, so I'll go over the choices with you. Oops, sorry, this is minus, not equal. Yes. And total minus that we have there. Okay, so 1 minus the cosine over sine minus the sine over 1 plus the cosine is equal to 0. Okay, so that's what you would see in your textbook. Okay, so when you are looking at this problem on your textbook, the first thing you're going to do is write down what side you want to start with. You always start with the more complicated side. So in this case, it's going to be the left side. So we're just going to jot that down real quick with a less aggressive minus sign. And your reason, I usually do mine in like a certain color. So if you want to color code it, you can, or you can just put it in parentheses. Your first reason is always going to be given and what side you chose. So if you use the left-hand side, you're just going to say given LHS, left-hand side. If you choose the right side, you're going to do that. So that's what it stands for, left-hand side. Okay, we do have fractions. So a good strategy to use, because you can't replace with sine and cosine here, a good strategy with fractions is to multiply to get the LCD. So if I want to get the LCD, it's going to be sine multiplied by 1 plus the cosine. Okay, so I'm going to multiply this by 1 plus the cosine over 1 plus the cosine. And again, I know sometimes the hardest part is just doing the writing part, right? But that is very, very important that you can show those logical steps. Okay, so we're multiplying the first one by the denominator of the second term, so 1 plus cosine over itself. We're multiplying the second one by sine over sine. Okay, so your justification, you are just going to basically tell me what you're doing, which is multiply to get the LCD. That's your justification. Okay, you're multiplying to get your least common denominator. Alright, so then when we multiply 1 plus cosine times 1 minus cosine, remember with these you FOIL. Okay, 1 times 1 is going to be 1. Cosine and negative cosine cancels, so I have 1 minus the cosine squared. And then this is going to be minus sine times sine is sine squared. And it doesn't matter what order you write these in, but this is going to be your denominator. 1 plus cosine times the sine. Okay, so how did we get that? We subtracted the fractions. You can just write subtract. In one of my earlier classes, they were confused how I went from this step to this step, so I just added the fractions for it to be helpful. Okay, so you're subtracting the fractions. Okay, now you might notice that when you multiplied this out, you had 1 minus the cosine squared. And what do we know 1 minus the cosine squared is equivalent to? Yep, so we can plug in the sine squared there. So So it'll be sine squared of theta minus sine squared of theta. This is honestly the part where sometimes people like skip this step, and you can't do that for these because your brain just works really fast, right? You're going to see what's starting to happen. You can see sine squared minus that is going to be 0. So then the wheels are going to turn. So you're just going to have to slow it down a little bit. Okay, so to get from here to here, you used a Pythagorean identity. We are going to abbreviate, but just for this first one, we're going to write out, it's the Pythagorean, oh, not theorem, right identity, the ID. Okay, and you're just going to tell me which one it is because there are 9 of them. So what you used is that sine squared was equal to 1 minus the cosine squared. Okay, so that's going to be your justification. The Pythagorean identity is that sine squared equals 1 minus cosine squared. And then from there, you're just going to subtract. Okay, so it's 0 over 1 plus cosine times the sine. And then what's your final answer going to be? 0. Okay, so it should equal that other side. Okay, and to get 0, all you did was divide. Okay, so you did 0 divided by this. Okay, so if you haven't finished that Chapter 7 preview worksheet, I'm going to give you time to work on that. If you have, I'm going to give you guys some time to start your homework, and we're going to look at the calendar together.